So, can you please tell me about yourself and about your experience?
Yeah, so I am a software engineer with around 2.2 years of experience, mainly specialized in the backend and full stack development. So my main technical skills are like Java, Spring Boot, and Angular also for the front end side. And alongside that, I have hands-on experience on AWS. So for that, I also have the solution architect certification, and I am currently enhancing my knowledge in Kubernetes and cloud native application deployment. So in my recent role, I was the part of the core development team for a job portal application. So I was basically responsible for designing and implementing robust REST APIs and writing, optimizing the stored procedures and overseeing key modules of the candidate workflows. So this project basically allowed me to collaborate closely with front-end team using Angular and to ensure smooth integration across microservices. So I also contributed to automating CI/CD pipelines using AWS services. Yeah, and I'm kind of eager to enhance my technical background and approach to new projects and continue my expanding my skills in scalable and cloud based solutions. So yeah, so that's what is about myself.
Okay, so you mentioned designing and implementing REST APIs for the job portal, right? So, can you walk me through the most challenging API you developed in this?
Yeah, one of the most challenging API was the candidate application submission API. So this API basically handled the complete workflow when a candidate applied for a job. So that basically involved multiple steps. So like validation of candidate data, checking job eligibility, and updating application status in the database. And also like it had how to we have to send the notification both to candidates and recruiter. So basically, the complexity came from the fact that this workflow touched multiple microservices and like the user service, job service, notification service, and all that. So ensuring the data consistency between or among all these microservices was kind of tricky because if one step failed, the entire transaction had to be rolled back to avoid the leaving any of the microservice having half completed state or half data or anywhere. So to handle this, basically we used Spring Boot with transactional boundaries for database operations. We also implemented and idempotency check so that repeated submission did not create like duplicate applications. And for the security purpose also, we applied JWT based security, and we also added asynchronous messaging using events for notifications so that the core API response was not delayed. So yeah, so we did all these things, and for also we added the logging and exception handling properly. So we followed all these steps in order to make it like more accurate and less vulnerable. So yeah.
Okay, can you explain me how did you ensure the communication between backend and Angular, like front end side? So, how basically all this integration happened, and any kind of security thing you used? So, can you explain?
Yeah, so we ensured like smooth communication between Angular front end and the Spring Boot backend by exposing the RESTful APIs from the backend and consuming them in Angular using HTTP client. So the backend was responsible only for business logic and data persistence, while the front end handled the like presentation thing only. So we followed a JSON-based contract between the two, and that made the integration like kind of a straightforward. So for local development, we used Angular's proxy configuration to redirect API calls to Spring Boot server and avoid any kind of issues. So in production, the Angular app was built and deployed as a static files inside the Spring Boot projects, inside the resources in a static folder. So the same Spring Boot server could save both APIs and front end also. So authentication was handled using the JWT tokens we were using for that, and Angular stored the tokens securely, and each request included the authorization header. For a testing purpose, we were using the Swagger for that. So yeah, so basically from the front end and to back end, this is what the whole steps we followed. So yeah.
Okay. Okay, can you explain whatever you know about the JWT tokens?
Yeah, sure. So JWT basically stands for JSON Web Token. So that is like it has basically three parts. So one is the header, the first part, and second part is the payload part, and the third part is the signature. So header basically will be having some kind of algorithm, and also the type of token which we are sending. So that is the header, and payload will be like a kind of a JSON structure. So whatever the like actual payload we are trying to send, so that will be the payload part. And like what kind of, for example, let's say any user is getting logged in, so it will payload will usually will have that user information, like login user, what role it will have, and when it is going to expire. So all those information will be there. And then the last part will be the signature. So that is used to verify the token, like we have to ensure that token was not tampered, and whatever the header is there and payload is there, so that we encode it. So yeah, so that is what is the signature. Now whenever let's say user logs in using the username and password, then backend verifies the credential and then token is issued. So there will be a token is signed with the secret private key, and the token is returned to the client, and client stores it like in usually in memory or local storage, and then subsequent request client sends the JWT in the authorization header, and then backend verifies the signature and expiry, and if it is valid then request processed, and if it is invalid or expired then 401 unauthorized is returned. So this is what is the whole flow of this JWT we follow from login to getting the request from the microservices. So yeah.
Okay, okay. Okay, while making these requests, have you ever faced CORS, cross origin resource sharing? Do you know about it?
Yeah, so CORS, like that is a browser security feature that controls like how resources like APIs can be requested from the different origin, like domain, protocol or port, that the web page was loaded from so that is what it is. And for example, suppose our Angular app is running on some localhost like 4200, and Spring Boot backend is running on the localhost 8080. So since here the port is different, the front end calling the backend is like cross region request. Okay, and the browser will block it unless the backend explicitly allows it. So this is what is the whole concept of CORS. So basically, whenever we write the code in Spring Boot, so like while registry, like we just say allowed origin, and there we can mention like from which URL if request is coming, then it should be allowed. So kind of. So yeah, so those things are there. So yeah.
Okay, can you tell me the difference between request param, path variable, and request body?
Yeah, so basically all these annotations we use in the API call. So request param basically suppose whenever we have any URL request coming, and that request is something like let's say search and then question mark, then let's say a title equal to some xyz, and then ampersand of and location equal to like some location. So this title and this location can be fetched or can be retrieved as a part of request param in the controller of a Spring Boot application what we write. So that's what is at request param. But let's say suppose we have a URL like let's say jobs and then forward slash let's say some number. Okay, so that number basically the job, it is something like jobs equal to 101 or whatever the job number is. Then that basically the forward slash can be captured with the path variable in a Spring Boot controller. So that's what is the path variable. And then coming to request body is basically that is used to bind the request body like JSON or XML to the Java object. So let's say we have any let's say job object is there, and it has let's say job title and job location. These two properties are there, let's say. So like in add request body, then this job object we can give this job whatever the properties are there, so that will be mapped with this, so in the input parameter. So yeah, so that's what is the request body. So in short, all these three are the part of the way how we get make the API calls.
Okay, so can you tell me when we use request param and when we should go for the path variable? Because we can achieve the same thing using both of these, right?
Yeah, this is correct. The same thing can be achieved using both of these, but there is one difference. Like whenever we are using at request param, then we can use this when the value is suppose let's say any value is optional, okay, or it may have some default value, okay, or let's say it is getting used for some filtering or for searching. So in that case, we should go for the request param. Okay, but path variable is used whenever the value is mandatory to identify a specific resource in the path. So whenever it is mandatory, then we can go for the path variable. So basically, path variable is mandatory resource ID in the URL path, while resource param is for the optional query parameter like filters and pagination and all. So yeah, so that's what is the difference between these two.
Okay, fine. So can you tell me what is the default logging framework in Spring Boot?
Yeah, the default logging framework is logback in Spring Boot. So Spring Boot basically comes with the pre-configured with logback. So we don't need to add any dependency for basic logging. So it can support like trace, debug, info, warn, error, all that. So yeah, so that's what is the default.
Okay. Okay, so let's say if I want to change that default logging, so for that what we need to do?
Yeah, to change that default logging in Spring Boot, we can follow like let's say we have the Maven project. Then in pom.xml, we let's say if we want to use log4j too. Okay, so the corresponding dependency like Spring Boot starter log4j2 we can add there, and then we can configure logging in application properties or YAML file whatever we are using. So there we can set the properties specific to the new framework. Okay, and then we can use the framework specific configuration files. So like log4j2 XML will be there, so that we can use it. So in code wise there will be no change, so only this much of will once we do, then we will be able to use log4j2. So yeah.
Okay, do you know how to implement asynchronous logging in Spring Boot?
Yeah, in case of log4j2, I think we have one tag called async logger, so that we can use, or by making the entire loggers asynchronous, so that we can do that tag we can use to do that. Yeah.
And do you know the difference between self4j and log4j2?
Yeah, Sol4j we can say the abstraction layer over the multiple logging frameworks. So that is kind of abstraction layer, and log4j2 is the specific logging implementation. So yeah.
Okay. Okay, can you tell me what is auto configuration in Spring Boot?
Yeah, auto configuration is a mechanism that automatically configures the Spring Beans and application settings based on the class path and beans defined and uh, property settings. So it basically helps the developers to reduce the boilerplate configurations. So lots of codes we don't have to configure, it is done automatically. So this is actually automatically included whenever we write at date of a Spring Boot application, right? So this is one of the part of that. So we don't have to manually do it. It is automatically done as soon as we add this logging annotation, this annotation at date of Spring Boot application. So yeah.
Okay, can you tell me how does Spring Boot handles dependency injection?
Yeah, dependency injection is a design pattern where an object receives its dependencies from the external resource rather than the creating them itself. So Spring Boot builds on the Spring framework. So dependency injection works the same way basically. So classes annotated with add component or add service, add repository, add controller. So all of them are automatically detected via the component scanning. So whenever we say that a component is scan, so it will be done automatically. We don't have to explicitly do anything. So also beans wherever we have annotations like add date of bean, add configuration, so they are also automatically included. And uh, dependency injection basically that can be done using the three ways like either constructor injection, setter injection, or field injection. So mostly we prefer constructor injection, that is the best way we should do. So that is how like basically it can be injected. So yeah.
Okay, can you tell me why constructor injection is considered as the better way to inject?
Yeah, so there are multiple regions we can say. So um, dependencies can mark final, so ensuring they cannot be changed after object creation, so which make the class more robust. So that is why basically constructor is like injection is more preferred. And also all required dependency must be provided at object creation, so that avoids any kind of null references. And also like uh, whenever suppose if we are using circular suppose whenever we are using field injection, um, then there are the chances of having the circular dependency problem. But unlike the field injection, constructor injection detects the circular dependencies at the startup itself. So it prevents the it prevents the start of the application itself, and it just there and there itself it stops. So that is also one advantage is there. So that is why it is considered as much better. Yeah.
Okay, so how do you implement pagination and sorting in Spring Boot?
Yeah, Spring Boot uses Spring Data JPA to simplify pagination and sorting of database results. So, like it has pageable. So, whenever suppose wherever we are writing the JPA repository, let's say any repository we are writing, and that extends JPA repository, and then it will provide the page. Then find by whatever method is there we can write it, and the pageable is the one of the parameter it also provides. So that is how we can do that at the JPA repository level. And also whenever we write the controller, so there also we can use like page object, and also in the service in the service class, so we can give the like whatever the size we want. And also like page number what it will be, like let's say we give page number equal to 1 and size 10, so it will take the first 10 objects. And if we give page number equal to 2 and size equal to 10, then it will take the like next 10 objects like. maybe 11 to 20 like that. So that is how this whole paging concept works, and yeah, that is how we can do it. Yes.
Okay, can you tell me what is the difference between monolithic and microservices architecture?
Yeah, in a monolithic architecture, the entire application is built as a single unit, so that makes the development and testing like simpler initially, but as the application grows it becomes harder to maintain, scale and deploy. So any change in a module requires the redeploying the entire application, and a single failure can affect the whole system. So microservices architecture, on the other hand, that decomposes the application into multiple small services or modules, we can say. So they can be developed, deployed, and scaled independently. So each service can use its own database or technologies. Like one can be like in Java, another can be in Python or .NET, whatever is best suited for that. And also the failure in one service does not bring down the entire system. So yeah, so that's what is the main difference. And also the communication, monitoring and all this can be done like with there are various ways, so that can be done. So that's what is the difference between these two. Yeah.
Okay, so what is service discovery?
Yeah, service discovery is a mechanism used in microservices architecture to allow service to dynamically find and communicate with each other. So, in a distributed system, instances of a service may start, stop, or change location dynamically. So, a service registry like Eureka usually I have used. So, that keeps track of available services instances. So, when a service needs to communicate with another one, so it requires the registry to obtain the instance address instead of relying on the hard-coded URL. So that this URL is basically dynamically generated, and on demand it can be shared to the whatever microservice is asking for. So this basically ensures the services can scale horizontally and maintain the high availability without manual configuration of endpoints. So yeah.
So, what do you mean by scaling horizontally in microservices?
Yeah, so basically, horizontal scaling means the adding more instances of a service to handle increased load. So suppose if we have any, let's say, user service running on one server, so if traffic increases, so we need to deploy, let's say, three more instances we can deploy of the user service, so behind the load balancer. So uh, whenever the more traffic increases, so all those traffic can be distributed to all these different instances. So as per the load, we can have more and more number of instances. So that's what is called the horizontal scaling. On the other hand, vertical scaling is also there. So that like is something like adding more resources, CPU, RAM to a single server itself to handle the increased load. So that usually happens in the monolithic application. So if suppose more number of load is coming, so we cannot change the server. It will be in the single server itself, and if that is down, means the whole application will be down. So we will have to increase the server running the user service from, let's say, if 4 CPUs and 8 GB RAM is there, then we might need to use 8 CPUs and 16 GB RAM or something like that. So that's the difference between these two basically. Yeah.
So, what is API gateway?
Yeah, API gateway is a, we can say, single entry point for client request in a microservices ecosystem. So it acts as a reverse proxy routing request to the appropriate microservices while providing additional features like authentication, rate limiting, logging, load balancing, monitoring. So all those things can be done here. So the gateway basically helps to decouple clients from the internal services. So it hides the complexity of multiple endpoints. So if suppose we are using any client or UI uh, has some endpoints, so and that is trying to call the microservice. So it always has to call the single like same microservice. Always it has to call. So it does not. So the service will be same, and only the endpoints will be changed, but it won't go to the different, like let's say we have user service, logging service, or different services. So it won't go to user service, logging service, or different services. It will always go to the that single API gateway service only. So that's what is the API gateway.
Do you know what is CQRS?
CQRS means I think command query responsibility segregation, right?
Yes.
Yeah, so that is design pattern that separates the read and write operation into different models. So commands modify data while queries retrieve the data. So this separation allows each model to be optimized for its specific purpose. So that improves the performance and scalability. So for example, a read model can be denormalized for fast queries, while a write model enforces strict business rule. CQRS so is basically often used in event driven system and works well with event sourcing, so where all state changes are stored as a sequence of events. So yeah, so that is what is CQRS.
Okay, can you tell me how do you monitor logs in the distributed microsystem services?
Yeah, monitoring logs in a microservices architecture, like that is done using the centralized logging solution like ELK stack, so Elasticsearch log stacks and Kibana. So that is usually used. So logs from the each service are collected, aggregated, and made searchable in a central location. So using correlation IDs, a unique identifier attached to each request, and developers can trace the flow of a single request across the multiple services. So monitoring tools combined with a Spring Boot actuator endpoints, so that provide the metric and health checks for better observability and debugging. So that is how we can monitor the logs. So yeah.
So can you tell me how do you handle API gateway failure?
Yeah, API gateway basically, as I explained earlier, like it is a single entry point for microservices. So that makes a potential single point of failure also. So to get rid of this, multiple gateway instances can be deployed behind a load balancer that we can do. So that will basically ensure the traffic is routed if to like if suppose any one of the microservices load balancer is failing, so whatever the healthy instance is there, it will route to that one. So gateways should implement retry and fallback mechanism, so for downstream services failures. And in the fallback again we can write out like in the fallback what need to be done, so that code we can write there. So health checks and monitoring help detect failures quickly, and it allows the traffic to be redirected or like throttled to different instances. So that's what we should do in case of the failures. Yeah.
Okay, can you tell me the concept of threads in Java?
Yeah, in Java, like a process is a program in execution, and threads are the smaller, lightweight sub-process that run within that process. So each thread represents an independent path of execution, so that allows multiple tasks to be performed concurrently within a same program. So let's say, for example, if in a text editor, operations like spell checking or syntax highlighting and all, like multiple things we can do simultaneously. So with each that handled by the separate thread. So threads share the same memory space of the parent process. So that makes the communication easier, but requires like careful synchronization to avoid the like different conditions. So basically this design improves the application performance, responsiveness, and resource utilization. So that's what is all about threads.
Okay, so in Java, how do we implement it?
Yeah, in Java, it can be done using two ways. One is using extending the thread class, and second one is using the implementing the runnable interface. So we can create a new class that extends the thread and override the run method, so that contains the code to be executed by the thread. So that can be done using the extend class. So after creating the instance, once you create the thread using the start method, so that is how the thread is generated. So that is done using the extending the thread class. And for the implementing the runnable interface, so basically this approach is preferred because it allows our class to extend another class if needed. So we implement the run method and create a thread object and pass the runnable instance to it, then call the start method to run the thread. So that's are the like these are the two ways we can do it. Yeah.
Okay, so how do threads communicate with each other?
Yeah, threads in Java communicate with each other and coordinate their execution primarily using methods such as wait, notify, sleep. So all these methods are there. So the wait method allows the thread to pause its execution and release the lock it holds, and waiting for another thread to notify it when it can resume. And the notify and notify all method are used to wake up the thread that are waiting for a particular condition to be met. And additionally, thread can communicate using shared objects and synchronized blocks or high level concurrency utilizes from the like java.util.concurrent package. So like we have locks and blocking queue and all. So yeah, so that is how threads can communicate with each other.
Okay, so what about the executor services? Do you know about it?
Yeah, executor service is a part of like Java has like java.util.concurrent package, and it provides a high level API for managing threads. So instead of manually creating and starting individual threads, executor service allows us to submit the task like implementing runnable or callable to thread pool. So that handles the thread creation, scheduling, and execution. So we use it because to create a new thread for every task can be expensive and can uh, highly use the system resources. So thread pool reuses a fixed number of threads to execute the multiple tasks efficiently. So that's what is the executor service. Yeah.
Okay, can you tell me what is the role of constructor in object creation?
Yeah, a class in Java, like that is what is the blueprint for creating the objects and defining the structure and behavior that all instances of that class will have. And a constructor is a special method that is invoked automatically when an object is created, and its primary role is to initialize the object state with specific values. So it allows the creation of multiple variations of an object. So like if we are giving like different parameters, so based on that it can create like differently. They also support constructor overloading, enabling multiple ways to create the objects with different initialization, making object creation flexible and intuitive. So that's what constructor comes into picture while object creation. Yeah.
Okay, can you tell me, can a constructor be inherited in Java?
Constructor cannot be inherited in Java. However, a subclass can initialize its parent class by explicitly calling the parent constructor using the super keyword, either with or without parameter. So this ensures that the parent class is properly initialized before the subclass adds its own state or behavior. So if no super method call is provided, Java implicitly calls the no argument constructor of the parent class, and if it does not exist, a compilation error occurs. So that's what.
And can you instantiate an abstract class?
No, we cannot. But if we implement all abstract classes, abstract methods via subclasses, then we can create an object. So yeah.
Okay, can you tell me what are the main features of Java 8?
Yeah, Java 8 has various features like lambda expression, default and static methods, and interfaces, functional interface, datetime API, and method references. So these are the features it has. Yeah.
And what is lambda expression?
Yeah, lambda expression is a concise way of to represent an anonymous function in Java. So that allows us to pass behavior as a parameter. So for example, we have, let's say, parameter a comma b, and minus forward slash a plus b, that is the implementation of it. So that basically defines a function that adds two numbers lambda. So lambda are primarily used with functional interfaces, and they simplify collection, processing, event handling, and multi-threading code, so that reduce the boilerplate code, anonymous inner classes. So that is what is the lambda expression.
And what is stream API?
Yeah, Stream API provides a functional approach to process collections in Java 8. So that supports the operations like filter, map, reduce, sorted, and collection and all. So streams allow lazy evaluation, parallel processing, and cleaner code compared to traditional loops. And they do not modify the underlying collection, but it produces a new result based on the pipeline of operations. So that makes the data processing more expressive and efficient. So yeah.
And what are default and static methods in interfaces?
Yeah, default methods in interface, which provides a default implementation for a method without breaking the existing implementation. And a static method in interface are also allowed and belong to the interface itself rather than the instances. So these additions enable richer interface, backward compatibility, and code reuse while supporting multiple inheritance of behavior in a controlled way. So that's what is the default. Yeah.
Okay, so what is the difference between hash map and tree map?
Yeah, hash map stores entries in hash-based buckets, so that provides the constant time O of one access for get and put operation, but no ordering of keys. But tree map stores the entire entries in a red black tree form, so that maintains the sorted key order with a get put operation with O of log n time. So we can use hash map for fast access without ordering, and tree map we can use when sorted keys are required. So that's the difference between these two.
Okay, do you know fail fast and fail safe iterators?
Yeah, fail fast iterator like array list hash map. So those are the fail fast, and basically they immediately throw concrete modification exception if the collection is modified during the iteration. Okay, so suppose we are iterating it and this array list or hash map, and in the middle if you want to add something, modify something, so we will get concurrent modification exception. While we have another copy on array list concurrent hash map. So if we are using these, then we say it is fail safe iterators. So whenever we are performing any operation on a copy of the collection, so that allows safe concurrent modification without showing exception. So basically this works on the copy of that, like array list. For array list we have copied a right array list, so it creates the copy of that. So if anything modifying or anything is getting deleted, it won't throw any concurrent modification exception. So yeah.
Okay, what is the difference between queue and DQ? Do you know?
Yeah, queue is a works on first in first out structure like FIFO. So data structure used for this is FIFO for tasks like scheduling, linked list, priority queue, and all. And a DQ is like it is double-ended queue. So that allows the insertion and removal from the both ends. So that supports the stack like last in first out and first in first out operation like array DQ. So DQ are versatile and generally faster than the stack for LFO operations. Yeah.
Okay, coming to SQL, can you tell me the difference between where and having clause?
Yeah, where clause like it filters rows before grouping occurs, typically used with the select, update, or delete operations. And the having clause filters the group after an aggregation like sum, count, and average and all, and has been applied in a group by query. So essentially, where works on individual rows while having works on the aggregated data.
And what is the difference between truncate, delete, and drop?
Yeah, delete removes rows from a table based on a condition and can be rolled back. Truncate removes all rows from table without logging individual row deletion, and resetting int counters and usually cannot be rolled back to in most of the databases. And drop removes the entire table including the structured data and permission. So everything it will remove. So that's the difference between these three.
And what is the difference between char and varchar?
Char is a fixed length string that always uses like n characters, padding with spaces if necessary. And varchar is a variable length string that uses only the actual length of the data. So that saves the storage space. So we can use char for the fixed length values like let's say country code and all is there, and varchar for the variable length data like names or addresses and all.
Okay, so why not to use varchar only then?
Varchar only we cannot use because uh, like character like it stores the fixed length column, right? And varchar is a variable length column, but optimized way it will save, but it will also store the additional length also, like it has to calculate and then based on that it has to allocate and save the data. So some extra memory will always be occupied in that case also. So yeah.
Okay, okay.